Welcome to our journey through one of the most profound discoveries in science, the Big Bang Theory. This theory explains the origin of everything we see around us, from the smallest particles to the largest galaxies. It tells us how space, time, and matter came into existence approximately 13.8 billion years ago. In this presentation, we will explore how the universe began from an incredibly small point and expanded into the vast cosmos we observe today. The Big Bang Theory is a physical theory that describes how the universe expanded from an initial state of extreme density and temperature. This happened approximately 13.8 billion years ago. The universe started as a single infinitely hot and dense point, smaller than an atom. Then, it underwent rapid expansion and stretching, a process that continues even today. This expansion created all the space we see in the universe and set everything in motion. Before the Big Bang, all matter, energy, and even spacetime itself were concentrated in what scientists call a singularity. This was an infinitely small point with infinite density and infinite temperature. It's difficult to imagine, but everything that exists today was compressed into this single point. The singularity also marks the beginning of time itself. There was no before the singularity, because time as we know it started at this moment. Immediately after the Big Bang, the universe went through an incredibly rapid expansion called cosmic inflation. This happened between 10 to the power of negative 35 and 10 to the power of negative 33 seconds after the beginning. During this brief moment, the universe expanded by a factor of at least 10 to the power of 26 in every direction. This tremendous expansion created the uniformity and flatness that we observe in the universe today. As the universe expanded, it also cooled down, allowing fundamental particles to form. At 10 to the power of negative 6 seconds, quarks and gluons formed what's called a quark-gluon plasma. By 1 second after the Big Bang, these quarks combined to create protons and neutrons. At 3 minutes, the universe had cooled enough for protons and neutrons to fuse together, forming the first atomic nuclei. This process laid the foundation for all matter in the universe. For the first 380,000 years, the universe was opaque. Light could not travel freely because it was constantly scattered by free electrons. But then, a critical moment arrived called recombination. Electrons combined with protons to form neutral hydrogen atoms. This allowed light to separate from matter in a process called photon decoupling. For the first time, light could travel unimpeded through space. This ancient light still exists today as the cosmic microwave background radiation. In the beginning, all forces in nature were unified as one. As the universe cooled, they separated into 4 distinct fundamental forces. First is the gravitational force, which shapes cosmic structures and planetary systems. Second is the electromagnetic force, which binds atoms together and creates light. Third is the strong nuclear force, which holds atomic nuclei together. And fourth is the weak nuclear force, which controls radioactive decay. These 4 forces govern all interactions in the universe. Around 200 million years after the Big Bang, gravity began pulling hydrogen and helium together to form the first stars. These were called population 3 stars, made only of hydrogen and helium. By 400 million years, small galactic fragments started merging to form larger structures, creating the first galaxies. Inside these stars, a process called stellar nucleosynthesis began. Stars fused lighter elements into heavier ones, creating carbon, oxygen, iron, and all the elements we see today. This process continues in stars throughout the universe. Scientists have gathered strong evidence supporting the Big Bang Theory. First, there's the cosmic microwave background radiation, a uniform radiation detected from all directions in space. This is the remnant heat from the Big Bang itself. Second, observations show that distant galaxies are moving away from us, and their light shifts toward the red part of the spectrum. This redshift proves the universe is expanding. Third, the abundance of hydrogen, helium, and lithium in the universe matches exactly what the Big Bang Theory predicts. The universe we observe today has a surprising composition. Only 5% is made of ordinary matter, the stuff that makes up stars, planets, and everything we can see. 27% is dark matter, an invisible form of matter that holds galaxies together through gravity. We can't see it, but we know it exists because of its gravitational effects. The remaining 68% is dark energy, a mysterious force that's causing the expansion of the universe to accelerate. Scientists are still working to understand both dark matter and dark energy. Let's review the timeline of cosmic events. At 0 seconds, the Big Bang occurred along with cosmic inflation. At 10 to the power of -6 seconds, quarks formed protons and neutrons. At 3 minutes, atomic nuclei formed. At 380,000 years, the first atoms formed and light could travel freely. At 200 million years, the first stars ignited. And now, 13.8 billion years after the Big Bang, we have the present-day universe with billions of galaxies, each containing billions of stars. The Big Bang Theory tells an incredible story. From infinite density, the universe expanded to infinite size. From pure energy, it created complex structures like galaxies, stars, and planets. From a singularity 13.8 billion years ago emerged the vast cosmos we observe today. This journey from the smallest point imaginable to the grandest structures in existence is the remarkable story of our universe. And the most amazing part is that we are made of atoms that were forged in the hearts of ancient stars, making us truly a part of this cosmic journey.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.